Welcome back to the next video, and we're going to start with reseating all of these chips. I've got the main CPU out. It came out of that socket there. And if you're wondering how I pull my chips out, typically I use a flathead screwdriver. However, I'm employing the help of a chainsaw screwdriver in this case because it has a flatter, wider tip to it. I also found that this little keycap puller tool that came with my Keychron keyboard has actually worked really well for pulling the smaller chips. So I'll show you if I just latch on here, get the little edges underneath it and kind of give it a little wiggle and pull, and then they come right off. So I've gotten to the one socket here that's particularly corroded, and it was actually kind of hard to pull that chip out. I've already sprayed some deoxit in there, but what I'm going to do now is I'm going to take my patented carburetor jet cleaning tool here, and I'm going to use one of the strands and just kind of poke it into each one of these pin sockets. Alright, so I was just fiddling with the power connector and I heard the CRT change, and if we go over here and actually look at it, you can see if I wiggle the connector around, hey, we get something. It's showing some signs of life. There we go. We got something. I finished reseating all the chips, but it's still very not happy. So I'll have to see if I can spot the problem somehow. I got some lines in there. Looks like yeah, just a little bit of everything. A little bit of the character ROM here and there. A little bit of corrupted memory. Yeah, just a little bit of everything. As soon as I tried to pull any of these out, they just broke away. So I'm going to have to re-crimp them and revert back to my pictures to see what the pinout was. I've adjusted the vertical holds until it actually stops. And get some chunks of memory. Looks like maybe just uninitialized RAM or something. Character ROM seems to be functioning. Huh, looks like those threes are on their side because the whole thing is actually like that. You got some bits in there that are changing constantly. I was doing some additional cleaning on this one chip here, and one of the legs that looked particularly corroded had just fallen right off. So to fix that, I'm just going to solder another little piece of copper on there and press that into the socket and hope it works. I've given the circuit board its first real bath with some Dawn soap, and then followed by a rinse with 91% alcohol to help give it a little extra drying power. I've blown it off now, and the board is about to go into a dehydrator for a few hours to bake off any moisture so that if and when we start soldering on this thing, we don't have, steam buildup and damaging parts further. It also just makes it, smell a lot nicer once you've gone through that whole process. Some of my boards that have gone through, the dirt come back smelling almost brand new, which is really, really nice. The plan is, if we get this back together after it's dried, I'm going to test it one more time to see if cleaning it didn't fix anything. And if, of course, when it doesn't work, I'm going to go through each and every one of these chips, find the pinouts, and mark the outputs so that we can test the outputs on an oscilloscope while it's running and see if they're switching as logic levels, if they're supposed to be. Any chip that's not switching or kind of in between levels, we're going to mark it with a red X on the top for further testing. I got it back together, but it still doesn't work. Something tells me these RAM chips don't belong in here. These are 81256s. If I'm not mistaken, that's data sheet says 262.144-bit DRAM too. So these are 256 bits. I wonder if somebody tried to like upgrade the memory in this one at some point, because this is a 64K model. These gold top chips I haven't looked up yet. Well, it seems as though I keep getting the same results, so I'm going to try some new old stock RAM in there. These are 8264-20s. I think they'll be fast enough, but if not, well, we'll probably get the same results. I was trying some other CPUs, and in the process broke off pin 1 of the original CPU. It was getting pretty badly corroded, so maybe, I don't think it'll do anything, but I'll pop this guy back in. The other CPUs didn't work either. I'm going to go ahead and try these 2764s. As you can see, I've already modified this one. Based off the pin out, I can actually pop this in with the front 4 pins hanging off the socket, and then just kind of solder my own bodge wires in. This one's already been programmed for the A-ROM. I'm going to pop it in, see what it does. I'm still trying to find a good 2764 in my stash that's, you know, actually programmable, because a lot of them have gone bad over the years. So I'll try just this one first. This is the only good one I've found so far, and we'll see where it goes. After looking through some of my stuff, I managed to find 2 more 2764s that look like new old stock. They don't look like they have any residue over the window, where there could have been anything. The pins look brand new. They don't have any scratches on them. This one I just finished programming. This one is about the same, except the pins are all bent up. They were in little plastic bags, and they're very dusty as well. And yeah, we'll see how these work. Okay, so changing the ROMs out hasn't yielded any positive results as of yet. So I'm going to start probing the CPU and other parts of the board and see where I get. First thing I really want to check is stuff like the wait state and the halt. So halt is 3 pins up from the bottom here. 1, 2, 3. And halt is active low, and it's a high. So it's not halted. However, if we probe some data lines, it kind of looks like they're in a tri-state. If I go to pin 30 here, which is A0, we should be seeing a lot of activity. 32, 31, 30, and nothing. And the next one down is ground. It should be 0. Refresh is 0 and 1. And it's kind of like a tri-state. Reset, active low, it's high, so we're not reset. So when we press the reset button, we should see that go low for a moment. And we saw a little blip there. 36, let's go back to 30 and try resetting again to see if maybe the CPU is running some code and it's just halting. 26, 27, 28, 29, 30. I don't see anything. How about the wait states? Let's see, the wait state is 24. And it is actually low. So it appears something is holding our wait state in an active state, inhibiting the CPU from functioning. Alright, pin 3 of U45 has been located. It's this little guy right here. There's pin 3. So let's turn this on and go back and see what's on the inputs of U45 here. It is low. That input is high, and pin 1 is low. Pin 1 goes to some other wait state. I think it's like a master wait state. So I traced it out and found that the R11 is right here, and it's right next to this 7416, which it's just acting like a buffer to that signal. When I pull it out, the signal goes high, and that chip outputs in high, outputs a high signal to the CPU wait, and the CPU is actually still not running from what I can tell. And you know what? I'm just going to leave this chip out for now, and I'm going to probe the CPU some more with that chip out so that we're not getting a wait state. What do you know? I tried a different CPU in after taking that chip out, And I've got a cast question mark on the screen. Hey, it's something. Very cool. Let's try pressing enter and see if the keyboard works. I don't have no idea if it will. It does. Alright. Radio Shack Model 3 Basic. Says it's ready. Awesome. So now I gotta figure out why that signal is getting held high. So maybe I spoke too soon, but I realized that I had the vertical hold adjusted so it would keep it one place. And the moment I pressed the reset button, it jumped to a different vertical position. And that reminded me that I had adjusted the vertical hold to make it steady, but I think I'm still not getting a vertical sync signal. I went ahead and tried the original ROM chips since I had it. I know that the rest of the circuit is working enough to boot, and sure enough, they don't work. So something happened in the past that took out these two ROM chips, the CPU, and something else. Okay, I went ahead and tried a different 7416 in there, no change, and then I looked at the schematics and found that it gets its signal from this little FDC chip, 24-pin guy. I think it's a Western Digital. I think it's part of the drive control system. This guy right here. I'll read it off. 437V4558 VC2070. Looks like Tandy part number 8040544. And if I plug the chip back in, of course, it doesn't boot. 2 volts per division. And as you can see, it kind of goes up to 2 volts. Hints to me that either this is a tri-state output, which I doubt, or this chip is bad and it's not outputting a definitive 0 or 1. I've decided to work on the video sync problem. I poked around on the board and I found that the vertical sync wasn't getting to the right places it needed to be, so I pulled the board out, washed it, dried it in the dehydrator for an hour. It smells a lot better now as well, so that's good. And that didn't seem to fix anything. On further inspection of the board, I found this little mylar capacitor. It looked like it may have been chewed on a little bit. So I checked it with an ohm meter, and it was a dead short to ground. I replaced it with 2 ceramic capacitors of a smaller size. I think 2.01, so close enough to 0.022 microfarads. And VSync is back. So we're back in business here. Now I just got to fix the floppy drive problem. Back to the disk drive interface oscillator. And this is the line right here, the weight line coming out of it that's holding up the CPU and causing this to show up on the display. I checked the oscillator on it and it's not oscillating. So either this chip is bad and that's why it's not oscillating, or the crystal is bad and the chip needs a clock signal before it'll release that line. So far I've replaced the CPU, the ROMs, a capacitor on the CRT driver, and bypassed the FDC timing chip. It boots into BASIC, but the cursor isn't blinking. I think the FDC timing chip might also play a role in the real-time clock chip that the Model 4 TRS-80 is advertised to have. I've also removed the reef capacitors from the power supply and replaced a bad MOT. Hopefully I can find a replacement for the FDC chip. I've since posted on the Vintage Computer Federation forums in hopes someone there knows where I can get one, or at least find enough information to reproduce a circuit with similar functionality. Anyways, I hope you enjoyed, and as always, thanks for watching. See you in the next video.